my name is Aspen and I work in the Garrett group at the University of Virginia in the United States. And we are really focusing on modeling experimental work using a Monte Carlo. So a Monte Carlo simulation basically is when you have particles on a surface and they can randomly move around. And in this model, we have what is called an off-lattice model, and so we have a surface, and the surface actually has periodic boundary conditions, which means that if you have a molecule over here, it can actually move all the way around to over here. So you can consider it like an infinite surface. And we have to do this because the models take so long to run that we need to do a much smaller surface than what you'd actually do in experiments. So the experiments we're focusing on are called temperature programmed desorption, which they are important because they focus on ices, and ices are in space, and in these ices you actually have a lot of complex chemistry occurring. And so in these experiments you have an ice and then you heat it up and you kind of just see what comes off using a mass spec. And based on the molecules within the ice, you'll see different peaks. So in this case you have a CO ice, and so you'll have a peak here for CO coming off of a CO-rich environment, and then CO coming from a water-rich environment, and then actually you'll have these peaks from when CO is trapped within the ice and then it can finally erupt from the ice once that water starts moving around. So in our model you can see that we deposit molecules onto a surface, and we do a specific temperature depending on what structure we want, because that is exactly what they do in experiments. So in this case we did a porous ice, which is very cold. And we warm it up and you see that CO on top actually starts to percolate down through the pores and actually becomes trapped. And by the end you see that the pores of water start to compact until the point where it's completely compacted, and then it'll start to come off the surface too. So in this case here, we did a mixed ice, and we actually saw that, so based on this peak here, you can see that CO is actually coming off when water comes off. So we are incorporating CO trapping, which is an essential part of these experiments. And in addition, we are also seeing that we are generating the right profile compared to these experiments. So we are seeing these multiple peak structures, indicating that we are in fact replicating the microscopic things that are occurring on the surface.